Namaskar. I am Professor Shivkumar Balagaon, Department of Humanities and Sciences, Walchand Institute of Technology, Solapur. In this video lecture, we are going to learn about assignment problems arising in the field of business and their method of solving. First of all, let us look at the learning outcome of this topic. At the end of this session, students will be able to understand the significance of assignment problems in real-life applications and apply the Hungarian assignment method to determine the optimal assignment. Now let us see the introduction and definition of the assignment problems. Assignment problems originates from the classical problems in which the objective is to assign number of jobs to the equal or unequal number of persons at a minimum cost or maximum profit. The definition of assignment problem is given here. Let us see what it is. Suppose there are n jobs to be performed and n persons are available for doing these jobs. Let C as A be the cost or payment if the ith person is assigned jth job. The problem of finding an assignment, that is, which job should be assigned to which person so that the total cost of performing all these jobs is minimum. This kind of problem is known as assignment problem. Now the cost or payments of persons to complete the assigned jobs can be given in a table which is called as cost matrix, or it is also called as effectiveness matrix. Now here the cost matrix is given. We need to understand the cost matrix. It is specially it is given in all the examples, all the problems on assignment problems. This matrix explains us the payment of the first person doing first job is C11. Similarly, the payment or the cost of first person doing the second job is C12. The cost or payment of first person doing the third job is C13 and so on. This is how this matrix is created, and this matrix is given in the problems. We will work on this particular matrix in order to obtain the required solution. Now we use the Hungarian assignment method to obtain the optimal solution to the given assignment problems. Hungarian assignment method is the step-by-step procedure to obtain the minimal assignment, and which is explained as below. There are near about 7 to 8 steps in this particular method. Let us discuss and describe each method one by one in detail. Step number 1, in which we will have to subtract the smallest element of each row of the cost matrix from all the elements of the respective rows. Step 2 is, further, we need to modify the resulting matrix by subtracting the smallest element of each column from all the elements of the respective columns. Thus, we get the first modified matrix. Now, moving on to the next step. Step 3 is more important. It's a very important part of the entire procedure. In the step number 3, we are expected to draw the minimum number of horizontal and vertical lines to cover all the zeros in the resulting matrix. Let capital N be the minimum number of lines. Now there can be two possibilities. First possibility is, if the minimum number of lines is equal to the number of rows or columns in a cost matrix given to us, then we can certainly see that an optimal assignment can be made. So we need to proceed for making zero assignment to get the required solution. That means we need to go to step number 6. The other possibility is, it may happen that number of minimum lines drawn to cover all the zeros, if it is less than number of rows or columns in a cost matrix, then we need to proceed to step number 4. Now let us look at what is step number 4. Step number 4 tells us to determine the smallest element in the matrix not covered by n lines, and subtract this element from all the uncovered elements and add the same element at the intersection of horizontal and vertical lines. Thus, we obtain the second modified matrix. Now, let us move on to the next step. Step number 5 says that we need to repeat the steps 3 and 4 until minimum number of lines becomes equal to the number of rows or columns of a given cost matrix. Now, the very important step, that is to make zero assignment. In this particular step, the guidelines about making zero assignment are given. The guideline is we need to examine the rows successively until a row-wise exactly single zero is found. Mark this zero by rectangle symbol to make the assignment. Then mark a cross over all zeros lying in the column of the marked zero, showing that they cannot be considered for future assignment. Continue in this manner until all the rows have been examined. Repeat the same procedure for columns also. Now step number 7. In this step, we are going to repeat step number 6 successively until one of the following situations arises. Either we get no unmarked zeros left, then process ends, or the situation will be if there are more than one unmarked zeros in any column or row, then mark a rectangle symbol on one of the unmarked zeros arbitrarily and mark a cross in the cells of remaining zeros in its row and column. Repeat the process until no unmarked zero is left in the matrix. After performing all these steps up to step number 7, we left with only one step, that is step number 8. So in this step, we get exactly one marked zero in each row and each column of the matrix which is obtained. The assignment corresponding to these marked zeros will give us the optimal assignment. Now there are two important notes to be taken into consideration. That is, the first note tells us that the assignment problem is said to be balanced assignment problem if the number of rows and number of columns are equal in a cost matrix. On the other hand, the assignment problem can be unbalanced assignment problem if the number of rows and number of columns are unequal in the cost matrix. This is all about a theoretical step-by-step explanation of the Hungarian assignment method in order to obtain an optimal solution to the given assignment problem. To make this video lecture, I have referred to two textbooks. One is Higher Engineering Mathematics by B.S. Grewal and the other is Operation Research by S.D. Sharma. That's it for today's video lecture. Thank you. Thank you very much.